Okay, for question 31, the directions say for any rhombus ABCD, I've sketched out a basic rhombus here. They did give us those vertices as are given in consecutive order. I started in the top left corner and I went clockwise. You can start anywhere and go either clockwise or counterclockwise. Again, but you have to go in consecutive order. And it says it wants us to decide whether the statement given is always, sometimes, or never true. It says to draw a sketch and explain your answer. We've already drawn that sketch. Now 31 says that line segment AC is congruent to line segment BD, meaning that their lengths are equal. As we look at this, AC is a diagonal, and so is BD. Okay, looking at this rhombus, we would have to say that in this case, this particular rhombus, the answer would be no. Diagonals being congruent is not a property of a rhombus unless that rhombus is a square. Now remember, rhombuses don't have to be squares, but by definition, a square has to be a rhombus because the definition of a square is a parallelogram with 4 congruent sides and 4 right angles. The definition of a rhombus is a parallelogram with 4 congruent sides. So therefore, a square always has the 4 congruent sides or the requirements necessary to be a rhombus. So, in this case, the sketch we have, you would say no. However, if we wanted a sketch to prove that it's sometimes true, what we could do is this. We could draw ourselves a square. Now again, there's the rhombus, this making it a square. And according to the Pythagorean theorem, this diagonal would have to be congruent to this one. So in this case, 31, the answer would be sometimes. The explanation would be if the rhombus is also a square. And if it's a square, it could also be a rectangle if you wanted to explain it that way. But I would say definitely sometimes if the rhombus is also a square, then its diagonals are congruent. And that's how I would solve question